Okay, folks, this is track and golf and whoever else. We're going to write formulas of those down on the last page, so you won't need that sheet. Okay, this is day 2 of a semester review for geometry. We left off on number 20. I think we're going to try to get through like 33 because that's the end of chapter 10. So starting with number 20. Number 20, you can do whatever you want on number 20. I don't really care. You can use SOHCAHTOA if you want to. Right?
But isn't the top one 45, so it's going to be 14, 14.
Yeah, so this is a 45, 45, 90 triangle, right? So if this guy's 14, this guy's also 14. Do you remember how to do this one? Yeah, it's 14 square roots of 2, right? That's what x will be, okay? Because the rule for a 45, 45, 90 triangle says that 1 square root of 2. So whatever this bottom guy is, you take him times the square root of 2 to get the hypotenuse. Now, if you don't remember that or don't know how to decode that, I have these two sides in blue. I'm going to do this part in blue. 14 is the adjacent side. X is the hypotenuse side. So adjacent and hypotenuse is cosine, right? So I've got cosine of 45 equals 14 over x, right? And then all I have to do, if x is in the bottom, how do I solve for x when it's in the bottom there? You switch them, right? So x is equal to 14 divided by cosine of 45, and you end up getting a decimal, which is going to end up being the same as 14 square roots of 2. So that's that, right? You can do it that way as well if you would like, but there is that, okay? Good. 21 is that same procedure. It is SOHCAHTOA. So we've got to decide. We can't do any little tricks because 64 degrees is not a special angle, okay? But we've got 64. What is x in relationship to 64? Opposite. 11 is adjacent. Which trig function do we use if it's opposite adjacent? TOA, tangent. Tangent, what goes inside of the tangent? 64, the angle, right? Equals, and the opposite one goes on top, and the adjacent one goes on the bottom. So now if I'm trying to solve for x, how do I get rid of the 11? Multiply by 11, right? 11 times tangent of 64, it should be bigger than 11.
22.6.
What? 22.6. And that is... whatever, 22.6. I knew that it was supposed to be bigger than 11 because if this is 64 degrees, this would have to be what, like 16 degrees? And 11 is opposite 16 degrees and 64 is opposite 22. That's got to be way bigger than 11, right? Like that should make sense, okay? So 22.6 is what x is. Got it? That was SOHCAHTOA stuff, okay? All right, 22. Am I going too fast? The answer was 22, and now we're on 22. Okay, angle T. How do I do this?
So, like, just make it X.
This is going to be SOHCAHTOA again, right?
But you have to use the
But you were solving for the angle. Okay, so I'm looking at T. What is 18 in relationship to T?
adjacent.
It looks like the adjacent, but it's actually the hypotenuse because hypotenuse trumps adjacent. And then 7 is the opposite. So which one of these do I use? Sine. Sine of what?
4. Ow.
Sine of X.
Sine of x or t, whatever, if we call this angle x right here, equals opposite over hypotenuse. So the opposite one is 7 over 18. So how do I get x out of the sine if we step?
Inverse sine.
Yeah, I do the inverse sine, which is the shift, as 7 over 18. And you get something like, I don't know,
22.9 degrees.
22.9 degrees. We're getting lots of 22s as an answer, okay? Does that seem reasonable? That would be 22.9. Yeah. 7 is a lot smaller in comparison to 18, right? So, not distributed very well. Whatever. Okay? That was 22. 23 and 24. Ooh. Solve the following triangle. Now, I will caution you. You ready for this one? Solve the following triangle. This is not a right triangle, which means we have to use the law of sines or the law of cosines. And I'm going to write the formula down here for you in just a second. But on the test, the actual test, I do not say solve the triangle because I don't want you to have to do all 3 things because it takes like 10 minutes to do that whole problem. So on the test, I might just say solve for angle C. Okay? So you only have to do 1 thing out of the 6 instead of, you know, whatever. Okay? So I'm going to do this. I'm going to go solve the triangle. So A, capital B, capital C, lowercase a, lowercase b, lowercase c. We have those numbers, right? 16, 20, 22. What is what?
Little a is 16.
Little a is
22.
22 because it's opposite.
Yeah.
Little c is
16.
16. Little b is 20. Do you see how that works? It goes by the opposites and things, right? Okay? Good, good? All right, so here's the deal. We are solving for an angle. Which one do you want to solve for? A? Sure. We're solving for an angle A. All right, we have 3 sides and 1 angle involved.
Sine.
So we have to use the law of,
Sines.
no,
Cosines.
law of cosines. Okay, now, real quick, I'm going to write down the law of cosines and then I'm going to write down a cheater formula for you. Ready? Law of cosines is c squared equals a squared plus b squared minus 2ab cosine of capital C. Okay? Now, don't start plugging stuff in yet because I'm going to show you how to cheat. Okay? But before I do that, if we're solving for A, if we're solving for A actually has to go in this spot, right? That means little a has to go in this spot. That means A is not A is actually little c, right? Does that make sense? And these are A's. Clear as mud?
Yeah.
Okay, A and A. If we're solving for A here, little A's got to go over there. They have to go opposite each other, whatever. Okay, but I'm going to show you the cheater formula. And when you're solving for an angle, you've got capital C right here. Okay, I have to do all of the shoving everything to the other side in order to solve for capital C, right? Okay, I'm going to show you a cheater formula. Ready? Write this down. This is the alternative to the law of cosines. So cosine of C equals a squared plus b squared minus c squared over 2ab. That is this equation flipped around and done all the other things too, right?
Okay, you couldn't tell us this when you were doing the lesson.
Because I wanted you to suffer a little bit. Okay?
Whatever.
So, now when we go to put stuff in, this is actually A, and this is actually A, right?
And A is
And little a is actually C and C, so I'm putting that in there, right? Okay? So I got my variables correct?
I'm erasing the other one.
Okay, sure. Well, you got to have the other one if you're solving for a side, though. That make sense?
Whatever.
Okay. So cosine of A equals, what goes first on the top?
C. So it'd be
16 squared plus
Plus
20 squared minus
22.
22 squared over 2 times
16.
16 times 20. Okay?
0.268.
0.268. That didn't seem right.
No.
It is, though. Because that's what cosine of A is. How do I get just A?
Oh, inverse.
I got to still do the inverse, right? Inverse cosine of that 0.268, right? You still got to do that.
Which will be 74.4.
74.4 for A. Whew. Okay, now what? Now what do you want to solve?
That's just one.
That's just one.
Now let's do C.
Now let's do C.
Yeah.
You're crazy, boy. All right, so if we're going to do C, then we can do the law of sines. And the law of sines is sine of A over A equals sine of B over B, which in this case is C because crazy boy over here wants to do C instead. I don't know why. Whatever. Okay, so we've got sine of 74.4 over 22 equals sine of C over 16. Then we cross multiply and divide. And that's what sine of C is. So you got to take the inverse.
Yeah. I don't really do that.
I got 44.
I got math error.
That's it.
You didn't do it right then. That's what that means.
And then don't they all add up to 1?
Yep, then they all add up to be 180, so then we can use that to solve for B. So add those together, subtract for 180. That is how we solve for B.
Got math error again.
What is wrong with you?
No, I got it.
You're just stupid. So I need to do sine 74.4
Close parentheses, times 16,
16
divided by 22.
divided by 22.
Then you go second sign of that
I got
answer.
Okay.
0.999.
I told you
What?
I got it.
Told you I got it.
What?
61.1.
61.1 degrees. Sounds good to me.
Wait,
What are you doing, Zach?
What are you trying to do?
I don't know.
Are you trying to solve for C?
So sin of 74 times 16 divided by 22.
Yep, but make sure that if it opens parentheses here on your sign, you close that. And then you gotta take inverse sine of that number.
Oh, inverse.
Yep, because that's what sine of C is. You're gonna get a decimal. If you get a decimal,
You know you did it wrong.
you know that you just gotta do one more step and take the inverse probably, right?
Probably sucks.
Okay, good. This is gonna be a hard, that's one of the hardest problems on the whole page.
That's a skipper.
That's a skipper.
Oh, I got
Isn't it 5 we get to
45.5.
skip?
You get to skip 5. Yep, yep. Okay, this one is solve the following triangle again. So, law of sines and law of cosines. A, B, C. Now again on the test, it won't be solve the following triangle. It'll be like solve for little a, right? Or something, right? Okay. Good, good? Okay, what do we know?
Angle
A
B.
is 37.
A is 37.
C is
C is 78.
8. Yeah, 78. And then little c is
Little c is 12. Okay, what can we solve for first?
B is 65.
B is 65 because they have to add up to be 180, right? Okay. All right, now what do you want to find first?
laws.
A.
B.
Let's go.
You want to go A? Okay, let's go A. And we can use the law of sines. Do you know, like, can you identify why, right? We have this group and we have this group, right? As long as we know, like, a married couple together, right? Like, I have C and C, right? I have a pair, like, that I know, right? So I have sine 78 over 12, whoop, equals sine 37 over A. Now I cross multiply and divide. Do you have to take the inverse?
No.
No, because A is just by himself. I just do that and divide by sine of 78. What do you get?
7.38.
7.38. Can I do the Pythagorean theorem to find B?
No.
This is not a right triangle. So now I got to do another one again. I'm just going to do sine 78 over 12 equals sine of 65 over B. So all I did was change this guy into the B instead. Cross multiply, divide. Sine 78, yep.
Sin 78.
Sin of 78, yeah, huh?
11.1.
11.1. Okay, all right, I'll take it. Okay. Woo! Man, oh man. All right, how was that? Those are the skippers. You guys can do them. You guys can do them. You're smart enough to figure that out. All right. Determine whether the following sides create a right, obtuse, or acute triangle. Okay, how do I know if a triangle's a right triangle?
They equal 0.
That's a coot.
If a squared plus b squared equals c squared, right?
Yeah.
But I do another test to see if it's obtuse or acute, right? So which side is A? 18. Which side is B?
27.
Ooh, they tried to trick you. Because they don't go in order, right? 31 is the biggest side, so don't let that trick you. Okay? Okay, so 18 squared, what is 18 squared? I don't know these numbers. That's too high. 324 is 18? Plus what's 27 squared? 729. And 31 squared is 961. If I add these two together, I get like, I don't know, 3, 5, 1053. Is that true? Okay, is it a right triangle? Because those are not equal, so it's not a right triangle. Obtuse or acute. Okay, here's how you decide. Which side is the biggest side? This one. My biggest side, which is this guy, is fairly small because the other ones are bigger than it, right? So I have a big side that's still kind of a small side, right? So is it going to be obtuse or acute? Acute, because in an obtuse triangle, you have a really, really big side, right? My big side is still fairly small because it's smaller than the other two. So that's why it's acute. Got it? Okay, we ended up with like this thing happening. So that's why it is acute. Good, good? You got a 33% chance of getting that one right. If you just guess. Yeah. Okay. 10. Chapter 10. The diameter of A is 10. Diameter means all the way across. So this whole distance is 10. Okay, what does that tell me?
It's 13.
Well,
This guy is 5. Okay, great. The diameter of B is 8. So this whole thing is 8, which means that this guy from here to here is 4. You see that? Like I have like all my things overlapping now. And then they say that AX, which is this little guy in green, is 3. Woo! Okay, so I've got 3 here.
Overlap.
This is 5, right? So how much is this?
2.
2.
So 2.
And then how much is this guy? 2 also, because this is 4. You see that? Like, if you are a messy labeler, it's hard to see. So what are we even finding? YB? YB is 2. Okay, inches, technically, you want to label. How's that? Good, good? Those ones you can kind of figure it out, maybe. All right. Was that it? Oh, no. No. I'm on the wrong page. I was like, we're not doing surface area today? That's because I'm in the wrong page, because I had to rescan. 27. Here we go. Find the radius of a circle that has a circumference of 36. Okay, what's the formula for circumference?
2 pi r squared.
2 pi r, there's no square. 2 pi r, okay? 2 pi r is the circumference, but we know that that's 36. 36 equals 2 pi r. So, how do I find the radius?
Divide by 2.
Divide by 2 pi. Now, when you do this, some of you are going to get the wrong answer because when you divide by 2 pi, you need to put parentheses around it, or you need to take 36 divided by 2 divided by pi so that the pi stays in the bottom, right? If you take 36 and you divide by 2 pi, and your calculator is not one of the calculators that like puts it on top of itself, right? What it's going to do is it's going to take 36 divided by 2, which is 18, and take that times pi as though the pi is in the top. You do not want the pi to be in the top, so you either have to put parentheses around the 2 pi when you do it, or if your fancy calculator does it where it's like a fraction thing, like make sure the 2 pi is in the bottom, or divide by 2, divide by pi, okay?
Yeah, the next one's kind of dumb. You kind of
5.73, and that is in meters.
You messed up on the next one.
I don't know. What you talking about?
You
Find the
100%
measure
messed
of
up.
DC.
What you talking about?
That's easy enough.
Yeah.
It literally gives us the answer.
Yeah, correct. How big is DC? What is the measure of DC? 100 degrees, right?
You meant to do that?
Yeah.
Why?
Well, because we don't know if it's 100 or if it's 50.
We know it's 100.
We like, well, now you know it's 100. Like we know it should be 100, right?
And it's
Yeah. Yeah, measure of DC is 100, and it is a minor. Even though it's an obtuse angle, it's a minor because minor is less than half a circle, right? So there you go. There you go. Okay, now we're talking about the measure of an arc in like inches, like the actual length of it, right? So LM, even though that's 100 degrees, yes, I want to know how long that is if the radius is 5. Now, if the radius is 5, take a look at this. Does this arc look longer than 5 or shorter than 5? Just by looking at distance. It looks longer, right? So I'm going to guess like maybe like 7 or 8, right?
Like
I don't know.
8.7.
Okay. So if we're talking this length right here, that has to do with circumference. How do you find circumference? 2 pi r. But the radius is 5. So the whole circumference would be 10 pi, but I don't want the whole circumference. I only want
times
100 out of 360. This is the fraction of the circle that I want, right? Okay? Or 10 over 36 or 5 over 18, whatever you want to multiply by, right? So when you do that, what do you get? 10 pi times 100 over 360. What do you get?
I got 8.73.
8.73. Okay, that sounds good. And that is in
You guessed.
inches, right?
No, it's 8.73.
8.73.
8.73.
Oh, you didn't guess, man.
Okay, does that make sense? You multiply by the fraction of the circle that you want. Good, good? Okay, all right. We're going to do these 3 first before we do 32. We'll do 32 last because the rule for these is like similar, right? So for 30, because they're intersecting outside of here, the rule is that you subtract and then what?
Divide by 2.
Subtract, then divide by 2. So I'm taking 105, which is this guy. I am subtracting 63. This is subtract and divide by 2. 105 minus 63 divided by 2 is 21 degrees. Does that seem reasonable for y?
Yeah.
Sure. Okay, let's go to 33. I'm going to bounce to 33 now. Okay, because they are intersecting inside the circle, this is a Add and divide by 2.
6, 7.
Okay, so 48 plus 38 divided by 2 is how much?
6, 7.
67, but that is not the right answer.
It's
What?
1 and 1, 3.
What?
I got 43.
You got 43? What?
Well,
The right answer
that's
is
86.
Yeah, 67 should not be the right answer. You got 43 here?
Well,
That should be the right answer.
86.
Yeah, I messed up.
43, but 43 is this angle and 43 is this angle. They want the measure of angle 2.
137.
Yeah, angle 2 is subtracting from 180, so be careful of that. 180 minus 43 is 137. There you go. Okay, does that make sense? That was an add and divide by 2. All right, 31, where it's like find the measure of angle R. Angle R is like on the edge of the circle. So what's the rule there? Just divide by 2. But what am I dividing by 2?
No, it's the
I want this little, the top of my ice cream cone. I'm going to take that top of the ice cream cone. I'm going to divide it by 2. But what is this?
100.
Like 120 and 140, if I add those two together, this is 260, right? But I take 360 minus 260. That gives me 100 degrees. This is 100, right? So what's angle R? 50, right? Sometimes you got to do a little investigative work before you get it done, right? Okay, so subtract, divide by 2, add, divide by 2, just divide by 2.
We had 32.
Okay? And 30, is this the same homework problem?
Yeah.
Well, hey, how about that? Okay, so look at this individually like you have 3 different ice cream cones, right? So if my ice cream cone's here and I have this going on here, I told you I think I like had a video of it, but some of you guys I'm sure didn't watch it. 14 is this guy. If one side of your ice cream cone is 14, the other side has to be a 14 as well, because if you have an ice cream cone that looks like this, it's going to fall off the side, right? Like if this is 14, this has to also be 14. If this is 18, this has to also be 18. But then I can find what this is, right? What's that? That's 8, because 26 minus 18 is 8, right? So then x is 8. X equals 8, but then they want the perimeter, right?
80.
Is it 80?
Probably.
I'm going to say units. It's not squared or anything like that. It's just units, okay?
Do we have to put units on the test?
No. Well, when we're doing surface area volume, I would like you to put like inches squared, inches cubed. That would be great. Yeah.
We're done now.
We'll see what mood I'm in that day if I count off for it, but just be safe and do it, right? Okay, we'll stop. Chapter 11 is all that's left, so one problem and then the back page. There we go.